Welcome back to my class. In our earlier few classes, we have already learned the condition of divisibility by numbers like 2, 4, 8, 3, 6, 9, 5, 10. In today's class, we will check the divisibility of a given number by 7, 11 and 13, and we will learn that what are the conditions of divisibility. So let's start the class. First, we will check the divisibility by 7 of a given number, and then we will follow by 11 and 13. For a two-digit number, we already remember the table, so there will be no problem to check the divisibility of a two-digit number by 7. It will be a bit difficult when it will be a three-digit number or more. So we will learn today the divisibility, the condition of divisibility by 7 for a 3 or more digit number, and we will learn this condition directly by example. Suppose for first example, the first number if we take as 3, 9, 888 and 38. So what we will do to check the condition is we will consider the digit at units place. Here it is 8, and we will multiply that digit at units place by 2. So here it will be 16, and then from that given number we will discard that digit, and from rest of the number that has rest of the digits, from that number we will subtract the number what we obtain by multiplying that digit at units place by 2. So here we will be subtracting 16 from this number. So we will get this number 398867, and this is a 6-digit number, and we are not sure whether this will be divisible by 7 or not. So we will proceed further and we will repeat the process that we have just completed. So here what we will do, again we will take the digit that we have at unit place, and then we will multiply that digit by 2. So this time it will be 14, and next we will discard that digit, and then from the rest of the number we will subtract that result of multiplication. So here it will be 14. We will get this result 39872. Again this is a 5-digit number, and we are not sure whether it will be divisible by 7 or not. So we will repeat the process. So here 2, we will take this digit 2 and it will be multiplied by again 2, and the result of multiplication will be 4. So from the rest of the number we will subtract 4. So it will be 3, then 8, here 9 and here 3. Again what we will do, we will take 3 and then we will multiply by 2. So it will be 6. So we will discard this digit, then we will subtract 6 from rest of the number. So it will be 392. Now again we are not sure, this is a 3-digit number, we are not sure. So what we will do is we will multiply 2 by again 2, and this will be 4. So we will discard this, and then we will subtract 4 from rest of the number, which now this will be 35. And we know that 35 is divisible by 7, where the quotient will be 5 and remainder will be 0. Since the last number 35 is completely divisible by 7, so our conclusion will be the given number wherefrom we started will be divisible by 7. Now we will take another example and we will test the divisibility by 7. So the given number is 248408. So what we will do is, this is a 6-digit number and we cannot say whether it will be divisible by 7 or not mostly. So we will follow the rules. We will take this digit at units place and we will multiply by 2. So the result of multiplication is 16, and what we will do, we will discard this digit and then we will subtract 16 from rest of the number. So it will be 24 here and then 248. So again what we will do, this is a 5-digit number, so we will multiply the digit at units place. So it will be 8. Now we will discard the first digit or digit at units place, and then we will subtract from rest of the numbers. So it will be 4, and here it will be 7, then here it will be 2474. So again what we will do, this is a 4-digit number, so 4 will be multiplied by 2, it will be 8, and that 8 we will subtract from this 3-digit number. So it will be 39 and then 2. This is a 3-digit number. So next what we will do, we will take this digit and we will multiply by 2. So it will be 18, and now from 23 we will subtract 18. So when we will subtract 18 from 23, it will be 5. And we know that 5 is not divisible by 7. If we do that, then quotient will be 0 and remainder will be 5. So here we are getting non-zero remainder. So the given number will not be divisible by 7, and that is what our conclusion is. Next we will see the condition of divisibility by 11 and 13. So first we will take a 2-digit number to check the divisibility. So here AB is a 2-digit number which has been expressed in expanded form like 10B plus A, which we are already familiar with. Now this can be further expressed as 11B minus B, that means it is 10B then plus A. So if we now separate this 11B and B, so it will be 11B and then it will be A minus B. Minus B we are taking here. Now 11B, we are checking the divisibility by 11, and in the first part we have two factors, 11 and B. Since already we have one factor 11, that means this number, this value is already a multiple of 11. So when we will divide by 11, it will always, the remainder of that division will be 0 and the quotient will be B. So we have no issue with this part. Only part that we have to focus on is this. So A minus B, if the difference of A and B, if that is divisible by 11, then the whole number will be divisible by 11. So that is the condition of divisibility by 11 in case of 2-digit number. Now suppose if we take a number 77, then 77 we know that is divisible by 11, and the quotient is 7 and remainder is 0. So here 77 can be represented as 10 multiplied by 7 and then plus 7. So further it can be expressed as 11 multiplied by 7 then minus 7 and then plus 7. So it will be 11 multiplied by 7, and here within bracket will be 7 minus 7, which is 0. Now we know that 0 is a special number which is divisible by any natural number. So here when we will be checking the condition of divisibility by 11, basically in this part here we will get 0 always. That means that A and B, the digits that we have at units place and tens place, they will be always same. So when we are dealing with a 2-digit number and when we are checking or testing the condition of divisibility by 11, both the digits at units place and tens place, when they are same, then that number will be divisible by 11. Now suppose if we take another 2-digit number which is 92, 92 we know that it is not divisible by 11. So 11 by 11 if we divide, then it will be 88 and we will have a non-zero remainder which is 4. And 99 if we further express in expanded form, then it will be 10 multiplied by 9 and then plus 2. So further it will be expressed as 11 multiplied by 9 then minus 9 and then plus 2. So it will be 11 multiplied by 9 and then it will be minus 9 plus 2. So this minus 9 plus 2 means minus 7, and minus 7 is not divisible by 11. So 92 is not divisible by 11. Next we will see the condition of divisibility by 11 for a 3-digit number. Now we will have A, B, C, a 3-digit number which can be expressed as 100 multiplied by C, then we will have 10 multiplied by B and then A. So this is the expanded form of a 3-digit number. Now it will be further written as 100C will be written as 99C plus C. So it gives 100C, right? Now 10B will be further written as 11B minus B. So it will give us 10b, and then a will remain a only. It can be further written as 99c, then plus 11b. We will combine these two terms, and then the remaining terms we will combine. So here we will have c, then plus a, and then minus b. Now the 99c and 11b, here the common factor is 11. So if we take 11 common, then it will be 9c, then plus b, and then we will have c plus a minus b. Now since in the first part we have one of the factors as 11, and this is a multiple of 11, so if we divide by 11, always the result of division will be 9c plus b, and the remainder will be 0. So we don't have any issue with the first part, and we have rearranged such a way that the first part will have, if we divide by 11, the first part will have 0 remainder. So if the second part, the result of this addition and subtraction, if this result, final result is 0, like the part when we verified for the 2-digit number, like here a minus b, when it is 0, then the whole number is divisible by 11. So here also, if c plus a minus b is 0, then the whole this 3-digit number will be divisible by 11. So here how is the condition? The third digit a and the first digit c, when we will add them, and then from that result of addition we will subtract the second digit, and if that result is 0, then the whole 3-digit number will be divisible by 11. Now we will check this condition of divisibility for a 3-digit number. Now let's take a 3-digit number 143. So 143, if we separately divide by 11, then it will be 11 ones 11, and then 3 3. So 11 3s are 33, and the remainder will be 0. There will be no remainder. That means 143 is divisible by 11. Now if we go by this condition, then here it can be further written as 11, then 9 multiplied by c. C means here 1, so it will be 1, then plus b means 4, and then here it will be c means 1, b, a means 3, and minus b means 4. So here this part is already divisible by 11, and from here we are getting 0. So when we are adding the digits of the first position and third position, and then from that result of addition, when we are subtracting the digit at second position, then we are getting this result 0, and 11 multiplied by whatever, and that result when we will divide by 11, we will get this as quotient, and the remainder will be 0. So this number will be divisible by 11. Let's check the divisibility by 11 of another 3-digit number, which is 567. Now 567, if we divide separately by 11, so it will be 11 5s are 55, then here we will have 17, 11 1s 11, and then here we will have 6. So here we are getting a non-zero remainder. Now if we go by this condition, then here 11, then here we will have within this bracket 9c. So 9 and c means what? C means the digit that we have at hundreds place. So it will be 5. So 9 multiplied by 5, and then b, the digit that we have at tens place. So it is 6. And then we will have c plus a minus b. So it will be 5 plus 7 minus 6. So 9 5s are 45, and then 6, it is 51. 51 multiplied by 11, whatever the value is, it will be divided by or divisible by 11, because here we have one of the factors as 11. And in the second part, here the result is 12 minus 6, which is 6. So it is not 0, it has some other non-zero value. So from this value we can conclude that since this is non-zero, so this whole number, whatever we have here, the 3-digit number, that will not be divisible by 11. Next we will check the divisibility by 11 for a 4-digit number. So let's take this 4-digit number, which can be further expressed in expanded form like this. Now it can be further expressed as 1000 D, so it can be further written as 1001D minus D. So that gives 1000D only. Now 100C can be further written as 99C plus C. Why we are arranging this way? Because 1001 is actually divisible by 11 and 99C is also divisible by 11. So that's why we are rearranging this way. Then 10b further can be written as 11b minus b, and then we have a. So if we rearrange these terms, 1001d and then 99c and then 11b, all the factors which is divisible by 11 we are combining together, and then the remaining terms means here we have a plus c minus b minus d. So here it will be a plus c and then minus b minus d. So if we take minus 1 common, then it will be minus b plus d, right? Minus b and then minus d, minus 1 multiplied by plus d. So here 1001, if we divide by 11, then it will be 91d. Then here it will be 9 11s are 99, so here it will be 9c, and then here it will be only b plus a minus c and then minus b plus d. So in the first part, what we can see here that it has two factors, 11 and this factor 91d plus 9c plus b, and that will be always constant for any 4-digit number. And if we divide this value by 11, then always we will give a non-zero remainder. So this is divisible and the quotient will be this value what we have within this bracket. So we don't have again any issue with this because we have rearranged such a way that this becomes divisible by 11. So in the next part, if this result of subtraction becomes 0, then the whole 4-digit number will be divisible by 11. So this is the condition of divisibility by 11 for any 4-digit number. Now here what is the condition? The digit that we have at first place, means at units place and at hundreds place, we will add them, and also separately we will add the digits that we have at tens place and thousands place, and then those two results will be subtracted from each other. So if this a plus c minus b plus d, the digits that we have at odd places and the digits that we have at even places, if that difference is divisible by 11, then the whole 4-digit number will be divisible by 11. So either this value has to be 0 or divisible by 11, and 0 is also is divisible by 11 or by it is divisible by any natural number. And that's what we have also seen for 2-digit number and 3-digit number as well. Here a minus b, if that difference is 0 or divisible by 11, then the 2-digit number will be divisible by 11. And in case of 3-digit number also, here if it is c plus a minus b, if it is 0, either 0 or a number which is divisible by 11, then the whole 3-digit number will be divisible by 11. And we took the example of 143 where we got this difference is 0. But if we had chosen a number where if this difference came as a number which is divisible by 11, then in that case also this 3-digit number would have been divisible by 11. So 2805, if we choose this number, then here separately if we evaluate the division by 11, then it will be 11 2s are 22, then we have 60, so 11 5s are 55, and then again we have 5, so it will be 11 5s are 55, and we have non-zero remainder. That means 2805 is divisible by 11. And now if we check the condition, then here what we will do is a plus c. So the digits that we have at units place and hundreds place, that we will add them. So 8 plus 5, the digits that we have at odd places, and then separately we will add the digits that we have at even places, means at tens place and thousands place. So here it will be 0 plus 2, and then we will subtract those two results of addition. If that is 0 or a number which is divisible by 11, then the whole 4-digit number, which is 2805 in this case, will be divisible by 11. So here we are getting 13 minus 2, which is 11. So easily we can say that 11 is a number which is divisible by 11. That means 2805 will be divisible by 11. Now suppose if we choose another number, say any arbitrary number 7219, let's check whether that number will be divisible by 11 or not. Say 7219, if we divide by 11 separately, then it will be 11 6 66, so it will be 6 and then 1. 11 5s are 55, then here it will be 6 and 9. 11 6 are 66, so here we are getting a non-zero remainder which is 3. And now if we check the conditions, so first we will add 2 and 9, the digits that we have at units and hundreds places, and then separately we will add the digits that we have at tens place and thousands place, so 1 and 7 this time, and then we will subtract those two results of addition. So from here we are getting 11, and from here we are getting 8, and the final value is 3. So it is neither 0 nor a number which is divisible by 11. That means 7219 will not be divisible by 11, and that we have already checked separately. So this is how we check the condition of divisibility by 11. Next we will check the condition of divisibility of a given number by 13. Condition number 1 is, suppose if we have a 2-digit number, first we will check for 2-digit number, then we will follow by a 3-digit and 4-digit number. So A, B, bar, the condition is if we have a 2-digit number like this, then what we will do is we will take the digit that we have at units place. So here it is A, and then we will multiply that digit by 4, and then we will add that result of multiplication with the rest of the number. Here it is only B because we chose a 2-digit number. Then that result of addition, if it is divisible by 13, then the whole number will be divisible by 13. So let's take one example, say 65. So 65, what we will do, we will take the digit at units place, which is 5, then we will multiply by 4, and then that result of multiplication we will add with the rest of the number that we have. So here the final result will be 20 plus 6, 26, and we know 26 is divisible by 13. So 65 is also divisible by 13. Now if we choose another number, say 91, so what we will do, 1 will be multiplied by 4, and then that will be added with 9. So what will be the value of this addition? It will be 4 plus 9, 13, and 13 is divisible by 13. So the 91, this number will be divisible by 13. Now we will take a 3-digit number. So this time it will be A, B, C. Now again the rule is same. We will multiply the digit that we have at units place, and then with that we will add the rest of the number, and this time it is CB. And if this result of addition is divisible by 13, then the whole number will be divisible by 13. So now let's choose a number, say 3 to 5. So 3 to 5, what we will do is first the digit that we have at units place we will multiply by 4, and that result of multiplication we will add with rest of the number, which this time which is 32. So what value this addition gives? This is 20 and then 32. 20 plus 32 is 52, and we know that 52 is divisible by 13, and even if we don't know whether 52 is divisible by 13 or not, then we can proceed one step more. So what we will do, again for 52 we will multiply the digit at units place by 4, and then we will add with the rest of the number. This time it will be 8 plus 5, which is 13. Now we cannot say that we don't know that whether 13 is divisible by 13 or not, because it is. So this is how we can check. Now if we choose another 3-digit number, say any number 7, 8, say 9, and if we want to check the divisibility, so by 13, then it will be 9 will be multiplied by 4, and then that result of multiplication will be added with the rest of the number. So this time it will be how much? It will be 36 and then 78. So it will be 114, and 114 further if we evaluate on 114, then it will be 4 multiplied by 4 and then it will be added with 11. So it will be 16, 16 and then 11. 16, 11 means 27. 27 we know that it is not divisible by 13 because 26 is divisible by 13. So now if we further if we divide this 7, 8, 9 by 13 separately, then it will be 6, then here it will be 78 and 0, here 9. So we are getting a non-zero remainder. That means 7, 8, 9 is not divisible by 13. So this is how we can check the divisibility by 13 for a 2-digit and 3-digit number. Now next we will go to a 4-digit number. So here again what we will do to check the condition, we will multiply again the digit what we have at units place by 4, and then that result of multiplication we will add with rest of the number, and if this result of addition is divisible by 13, then the whole 4-digit number is divisible by 13. This condition we have already checked, we have already learned. Now let's take a number which is 2119. Now 2119, let's check the divisibility separately by 13. Then 13 ones are 13, so here it will be 8, 1. 13 6 are 78, here it will be 3 and then 9. 13 3s are 39. That means 2119 is divisible by 13. Now let's check the condition the way we have learned. So here first 9 will be multiplied by 4 and then it will be added with 211. So what is the result of addition here? 4 9s are 36, 36, 37, 47. So 247. Now we may not answer that whether 247 is divisible by 13 or not. So we will again go further. So if we check now the condition of divisibility on 247, then it will be for the 7 will be multiplied by 4 and then it will be added with 24. So here it is 24 will be added with 4 7s are 28, so it will be 2 and then here it will be 52. So the result is 52 here, though we know that 52 is divisible by 13. But still, if we don't know, if we are not sure, then what we can do is 2 will be multiplied by 4 further and then that result of multiplication will add with 5. Now this number will come as 13 and 13 is divisible by 13. So that means we can finally conclude that 2119 is divisible by 13. So this is the one of the rules that we have learned for the divisibility by 13. And there is another rule which we can apply for a 4-digit onwards number, and that is, suppose if we have a 4-digit number A, B, C, D, then it will be, what we will do is first we will multiply the digit that we have at units place by 9, and then that result of multiplication we will subtract from the rest of the number, and this subtraction, this result of subtraction, if it is divisible by 13, then the whole number will be divisible by 13, and this logic works fine if the number is 4-digit or higher. For 2-digit and 3-digit number it sometimes may work or may not work, but the first rule that we have just learned, that will always work. So let's check the divisibility by 13 by using this second logic. Now again, if we go by the same number that we have just used, 2119, then what we will do, if we go by the second logic, then 9, the digit that we have at units place will be multiplied by 9, fine, and then that will be subtracted from rest of the numbers. So from 211 it will be subtracted. So if we do that, then 9 9s are 81, and from 211 if we subtract 81, then it will be 0, here it will have, we will have 3, and then here we will have 1, so 130. Though we know that 130 is a multiple of 13 only, but still if we are not sure the number that we will be getting here, then what we can do is we can further proceed. So 0 again will be multiplied by 9, and then that result of multiplication we will subtract from rest of the number, which is 13 this time. So here it will be 13 minus 0, so 13, and we know that 13 is divisible by 13. So 2119 will be divisible by 13. Now suppose if we choose a number which is 2121, so let's check whether this number will be divisible by 13 or not by using the second rule. So 2121, if we separately evaluate, if we separately divide by 13, then it will be 1, then here we will have 13, then 8 2s, 13 6 are 78, then we will have 4 1, 13 3s are 39, and we will have remainder 2, a non-zero remainder. That means 2121 is not divisible by 13. And if we go by this logic, the second logic that we have just learned, so what we will do is first we will multiply 1 by 9, and then that result of multiplication we will subtract from rest of the number, that means 212. So here what will be our result of subtraction? 2 from 212 we will subtract 9, so here it will be 203. Okay, fine. So 203, if we are not sure whether 203 is divisible by 13 or not, then further we will proceed. So here it will be 3 multiplied by 9, and then that result we will subtract from 20. 20 minus 27 is minus 7, and that is not divisible by 13. That means 2121 is not divisible by 13, and that we have already checked separately. I hope you have learned and you have enjoyed this class. Thank you.